All right, let's dive into a piece of technology that sounds, well, frankly, impossible. We're talking about a remote control that can target just one single molecule. But what's really wild is that the blueprint for this incredible device, it isn't from the future. It's already inside of us, and it's all around us.
Just think about that for a second. You're not aiming at your TV set. No, you're trying to hit one single invisible molecule floating somewhere in the room, and only that one molecule will actually respond to the signal. I mean, how could that even begin to work?
So to really get why this is such a monumental challenge, you have to understand the difference between shouting a command across a room and, say, whispering a secret to one specific person in a massive, noisy crowd. Let's break down the science behind it.
Okay, here's the fundamental difference. A standard remote, it's basically a floodlight. It just blasts out this wide beam of infrared light. Your TV just has to be somewhere in that general direction to catch it. But a molecular remote? Whoa. That's like having a key for one specific, incredibly complex lock. The principle here isn't just simple line-of-sight physics. It's perfect molecular chemistry. Our everyday remotes, they really just rely on a brute force approach. They essentially shout a command into the room, and the TV's simple little sensor is just sitting there, waiting to hear it. It's effective, for sure, but it is the absolute opposite of precise.
And this goes so far beyond just having good aim. I mean, a single drop of water contains over a quintillion molecules. So trying to send a signal to just one of them, that's like trying to find a single, specific grain of sand on every single beach on Earth. The scale of this challenge is just, it's almost beyond comprehension.
But what if this technology isn't something we need to invent from scratch? What if it's already been perfected, operating flawlessly for billions of years, not in some high-tech engineering lab, but somewhere much, much closer to home?
And there it is, the impossible technology we've been trying to wrap our heads around. It's biology. The most precise, most sophisticated remote controls in the entire universe are running the show inside of you this very moment.
At the very heart of it all is the biological receptor. Think of your body as this bustling city with millions of chemical messages flying around constantly. Each receptor is like a totally unique mailbox, a lock that will only open for one specific key, one specific signal, while completely ignoring all the other noise.
You know, this system is fundamental to everything you do. When your brain sends a signal to move your arm, neurotransmitter keys travel and find only the right muscle cell locks. When you get sick, your antibodies act like these microscopic heat-seeking missiles designed to lock onto one specific type of virus and absolutely nothing else. It's precision on a truly breathtaking scale. So, what happens when humanity discovers a blueprint this perfect just sitting there in nature? Well, we do what we do best. We learn from it, we copy it, and then we turn it into world-changing technology.
This is exactly where science takes that leap. By understanding nature's lock and key system, we've started building our own molecular keys, molecules designed to seek out and interact with only one specific target. We've essentially learned to speak nature's own language, but for our own purposes.
Over $200 billion. That's the projected global market for these targeted therapies. So, you see, this isn't some niche scientific curiosity. It's a full-blown revolution that is reshaping modern medicine as we speak.
So what does this precision actually mean in the real world? It means we can have chemotherapy that can hunt down and destroy cancer cells while leaving healthy cells unharmed, which dramatically reduces those grueling side effects. It's the magic behind rapid tests that can detect a single viral protein. And it's how we can build sensors sensitive enough to find one single molecule of a pollutant in an entire river. This is precision that saves lives.
This quote just perfectly captures the entire shift in thinking. We're moving away from the sledgehammer approach of medicine and into an era of what you could call molecular scalpels. We're no longer just fighting symptoms, we are fixing the problem at its absolute source.
And that brings us full circle. That fantastical remote control we imagined at the start, well, it wasn't some futuristic invention after all. It's the technology of life itself, perfected over billions of years of evolution. It seems the most sophisticated machine on Earth will always be the living cell.
We are just beginning to wield this incredible power. We can now target diseases, detect pollutants, and diagnose illnesses with pinpoint accuracy. So the question is no longer if we can hit a single molecular target. The real question is, with this almost godlike precision at our fingertips, what impossible problems should we aim for next?